course, the purpose of making this video is actually to give more clarification uh, on the topic we started the other time on logistic regression. Okay, so I actually walk you through a situation where when you are trying to characterize relationship between variables in such a way that the response variable is categorical, of course, we can no longer fit linear regression. The reason why we can no longer fit linear regression is because when we make an attempt to fit linear regression, the assumptions underlying the use of linear regression will be violated. I'm going to say that again. So the reason why the linear regression cannot be used, when we're trying to, characterize relationship between the categorical response and, predictors. A reason why we cannot use linear regression is because the assumptions will be of using that will be violated. And of course, when the assumptions underlying the use of a model is violated, it means we can not actually, that will undermine the performance of the model. And what are these assumptions am I talking about? Of course, I'm talking about the assumptions of linearity and assumptions of the constant variance. Okay, so give me 1 second. I'm actually going to project, the material I was walking through the other time, the one we actually did on Wednesday. Okay, so when you take a look at what I just projected now, it's basically, I call that logistic regression. I walk you through this in class on Wednesday, but I also want to go over that in this my short video. Initially, I've already introduced to you how the logistic regression look like. And of course, I think I remember I told you the logistic regression is actually, a transformation of a linear model, because I told you the linear model is no longer going to be appropriate, when the response variable is categorical. And of course, what I'm projecting to you now, this is a population or regression model rating as the expected value of y given s, equal to beta naught plus beta 1s. So this is actually the linear regression model. And of course, I said that since the response variable is categorical, we're actually going to talk about the log of the odd ratio. Okay, the log of the, when I talk about odd ratio, when you take a look at this guy here, it's basically this, right? Which is more or less like the probability of the characteristics of interest, which I'd actually call the probability of success in class. And of course, when you take a look at this guy, is actually, 1 minus that actually indicate the probability of failure, because, success and failure are mutually exclusive. Okay, so the log of, this is what we call the log of the odd ratio. So what we did in the logistic regression model, where the response variable is categorical, is actually to do the log transform, we're going to do the log of the odd ratio, equal to the beta naught plus the beta 1x. Okay, I think I walked you through that in my introduction on Monday, and I also emphasize on that on Wednesday. Okay, I actually, I also told you, since our response variable is categorical, is actually going to be regarded as a binary, 0 and 1. Okay, we are the expected value of y given, x equal to a predictor equal to the realized value. That is actually the probability of y equal to 1. Of course, 1 minus that, we actually be the probability of, of the other side of the coin. You get what I mean? So, which is more or less like the probability of failure. And of course, we're going to talk about, log odds, we're going to talk about odds, we're going to talk about probability. Okay, so this is the log odds, of course, which is going to be the ratio of the probability of success to the probability of failure. And of course, the range of the log odd is from negative infinity to the positive infinity. And of course, when you want to talk about hard, the hard this time around is you remove the log. Okay, we don't, so that is the difference between log odds and odds. Okay, the horse will actually be without log. Okay, and of course, it's just going to be the horse is just the ratio of the probability of success to the probability of failure. And of course, the range of that is actually going to be from 0 to infinity. Of course, the essence of fitting logistic regression model is actually to be able to determine the probability of the characteristics of interest given predictor. And of course, we expect that to have the range in the 0 to 1. Okay. Now, the next thing I actually want to talk about uh, is to look at the probability distribution of the response variable. Okay. If a W when you want to when the W is categorical, when it can take either 0 or 1, then of course it's a Bernoulli. Okay, Bernoulli distribution. We actually use that to model. If you really want to model, variable that have two possible outcome. You get what I mean, right? And you know what? When you are talking about logistic regression model, I told you the response variable has to be categorical. And of course, one of the example of that is when student apply for student loan, it's either you're going to be given or not, depending on some certain variables or predictor variable like credit score, the ability to pay, and so on like that. So because of that, it means, I told you one of the reason why you are not going to use, linear regression for this kind of situation. Initially, I told you that there's going to be violation of absorption, right, of linearity, of, using the linear regression. And of course, one of the violation here is that the underlying distribution, okay, for the response will no longer be normal. Okay, it's actually going to be Bernoulli or binomial. Okay, I'm still going to tell you the difference between Bernoulli and binomial. Okay, the Bernoulli is a probability distribution, to model a categorical variable when the sample size is 1. But when the sample size is more than 1, we're actually going to use binomial. Okay, binomial is a general case of Bernoulli. Okay, now the mean of the distribution of the Bernoulli is actually theta, which is more or less the probability of the characteristics of interest. And of course, the variance is actually the product of the probability of success and the probability of failure. And of course, I actually want to say, if we are looking at the effects of predictor on a categorical response, then I want to tell you what this guy mean here is that the expected values of the response, okay, given that I have a realized value, okay, for the predictor, you get what I mean? It's actually going to be equal to theta x. Okay, give me one second. I'm just going to check. Okay, so what I'm going to tell you now, we got a theta x, so which means we actually going to get different probability, okay, depending on the value of the predictor. So that is what I'm seeing here. But you know what? Now the major issue is, it means if I'm actually going to get um, different probability for, when I have different values of predictor, then what that means? If I want to look at the variance, okay, if I want to look at the variance of, of the rest of the categorical response given particular predictor. The variance I'm going to get for a particular values of the predictor will be different from the one I'm going to get for the other values of the predictor. And because of that, we say the variance is actually going to change when the predictor changes. Okay, so which means the assumptions of the constant variance has now been violated, and that is one of the reasons why we can no longer use linear regression model, for situation where the response variable is categorical. Okay, so I'm going to walk you through an example. Remember I was walking you through this in class when we're trying to look at the relationship between survivor and smoking. Okay, I'm going to say that again. We want to look at the relationship between survivor, okay, and smoking. Okay, because of that, we actually interview some women. Okay, we ask them question, okay, and whether they smoke or not, and we also take into consideration their age. And you know what, after 20 years, okay, after 20 years, okay, so what we actually did what we call a follow-up study, and we realized some of them are dead and some of them are still alive. And as you can see, right here, the case number one is still alive, and this is the age. This woman was age 23 when we interviewed him. So which means right now, okay, it's actually going to be 43 years. I tell you know that. So we're actually going to be coding alive as one. We're going to be coding dead as zero. And of course, this is our response variable right here. It's actually categorical. And of course, this is going to be the predictor. This predictor here is categorical. And of course, we have a quantitative predictor as well, age. So I just wanted to take note of that. So, and of course, what I was trying to say, page 3, okay, this person is no longer alive. Okay, we interview him, okay, when he was 71, after 20 years. So by the time we come back, when she was supposed to be 91, okay, she was dead already. Okay, so the question now is, we're trying to see what is the effect of what is the role, smoking habit or smoking nature, okay, of the respondent, as well as the age, okay, what did they actually play, okay, in the outcome. Of course, the outcome this time around is actually survival. Okay, so that is the data set that we have. And I want to tell you, I'm only showing the first 6 cases because I want to say 1,314 women, were actually interviewed. Okay, so just like what we said, we fitted a logistic regression, and if you really want to do that in R, or what you're just going to do, my data set needs to be imported, right? You get what I mean, right? So you're going to import this guy. The name of the data is actually that, and of course, the first model I actually want to consider, since I have 2 predictor, but 4 of us want to look at the effect of smoking, on the outcome. Okay, the outcome is actually whether she's alive or not. Okay, don't forget that we actually interview 1,000, 314 1,314 women. You get what I mean, right? Okay, so if you take a look at the result that we have now, when we're trying to look at the effect of whether they smoke or not, I told you the other time, you're actually seeing smoker yes, okay, in this output, because they had automatically coded smoker yes 1 and coded smoker no 0. Okay, I just wanted to take note of that. And of course, when you're fitting the model, I said you're going to write GLM, and you're actually going to indicate family equal to binomial. And why are you indicating family equal to binomial? It's simply because the the underlying probability distribution of a categorical response variable is actually a binomial distribution. And I told you, it is no longer, because we're no longer using the linear regression. And one of the reasons why we're not using linear regression is because the underlying distribution of the response, since it is now categorical, it is no longer going to be normal distribution. Okay, so we have the outputs right now. So take a look at that. So I want to tell you what you said in the estimate. We actually call them the log odd estimate. Okay, I'm going to say that again. Okay, so if you take a look at this particular estimate here, okay, they actually call, okay, log, okay, they actually call log odds. Okay, they actually call log odds. Okay, we call them log odd estimate. Okay, I just wanted to say that. Okay, so what you have in your output are called the log odd estimate. Okay, so what I'm trying to talk about now, the 0.78 052 and the 0.37858 are called the log odd estimate. Okay, so having noted that, another thing that I just also wanted to hear about is that when we're dealing with the when we're dealing with the linear regression the other time, you're going to notice that instead of having a z value, we have a t value. But that is the one of the difference between the outputs of logistic regression and linear regression. Of course, the GLM, in the logistic regression, we have a LM, which is what we call the linear model, but the GLM is more called the generalized, the linear model. Okay, like I told you the other time, that we need to generalize the linear model, that actually results into what I call the logistic regression model. Okay, so that is exactly what we have right now. Okay, so if you actually want to write your results, right now, okay, like I said, these are log odd estimate. I think I told you in class. What I told you in class is that we got two ways of presenting logistic regression result. You can have it in logit form, and we can have it in a probability form. Okay, now in logit form, of course, it's actually let me see if I actually provided for that before I move on. Okay, so okay, so if you take a look at this now, this is in logit form. So if I want to write the logit form of this guy now, so all what I'm just gonna do is to write log. Okay, when I write log, I'm talking about survivor, right? So the survivor is actually the outcome, right? So when I actually write survivor, then it's gonna be divided by 1 minus survivor. Okay, just give me 1 second. Give me 1 second. Just give me 1 second. I'm actually gonna be back. Just 1 second. Oh, okay. How are you today? Yeah, can you just give me like, is this your number? Yeah, because I'm making a recording now. I'm gonna call you back by 4 p.m. Okay, you're welcome. Okay, so sorry about that. I got a call, so I just have to answer that. Thank you so much. I'm actually, I was trying to talk about, um, you know, how do we write the fitted model? You get what I mean, right? So how do we write the fitted model here? So what we actually going to do is to write log, just like what I said the other time. Then I can actually use y, okay, probably y cap to denote the survivor. Then I'm going to say 1 minus y cap, okay. So when I say 1 minus y cap, then I'm actually going to write this guy here, okay, which is the intercept, right? So it's 0 um, 0.78, okay, 0.52, okay, then plus, because this guy is a positive right here, then I'm actually going to write the 0.378, okay. So when I write that, then I'm going to write smoker yes. Okay, now when you take a look at the model that I have right now, okay, when you take a look at the model that I actually have right now, so this is writing logistic regression in logit form. Okay, that is in logit form. Okay, now if this is in logit form, what you're actually going to do, you want to write it in probability form. I told you in class how you can write that in probability form. So when you follow what I did in class, writing that in probability form, okay, you are not going to talk about log anymore. It's actually going to, it's like solving for y, okay, solving for y, okay. You can follow up with what I mentioned in class for that. You get what I mean, right? Okay, so if you take a look at what I have here, it said the predicted probability of survival after 20 years for non-smoker. Okay, now if you want to answer the two questions right here, okay, you needed to for us have that in probability form. Okay, you need to have your model in probability form. So all what you're just going to do, if you have it in probability form, okay, it said what is the predicted probability of survivor after 20 years, okay, for non-smoker. So for non-smoker, in my probability form of a logistic regression model, I'm actually going to plug in 0 for smoker yes. Okay, for smoker yes, I'm actually going to plug in 0. When I plug in 0 for smoker yes, what I'm actually referring to, I'm actually talking about non-smoker. Okay, then and that would be able to give me the probability of survivor for non-smoker. Okay, like I said, we're actually going to make use of a probability form of a logistic regression model to do that, not the log odd. Okay, now we go for smoker on the other hand, okay, the in the probability form of a logistic regression model, or what I'm just going to do is to plug in 1. Okay, when I plug in 1, then I'm going to compute the probability. Okay, that is if you want to use the manual way. You get what I mean, right? If you want to use the manual way, that is basically what you're actually going to do. Okay, so as you can see, and here you can be able to answer a question on which group has a higher chance of survivor. Okay, is it smokers or not smokers? Of course, you will be able to see based on what you compute here and what you compute here. All what you just need to do is to compare the probability value. Okay, so when you compare the probability value, okay, the one that have a higher probability value is the particular one that have the higher chance of survivor. I'm going to say that again. When you use the probability form of a logistic regression model, like I said, you're actually going to plug in 0 for smoker, yes. That will be the coding for non-smoker. Then you're gonna calculate your probability, right? Then for the smoker, you're actually gonna plug in 1. Then you calculate your probability value. You get that, right? Then you're gonna compare the two probability value, and the one that have a higher probability value is actually the one that have the higher chance of survivor. Okay, the other time I actually use a single model, I mean a single predictor, okay, and I'm gonna consider additional predictor. But before I do that, I actually show you how you can do that how you can actually predict, okay, with the probability okay, now how you can predict the logos in R, okay, and and how you can actually predict odds, okay. Like I told you the other time, we got we have there's a difference between the probability between the log odd and odds. Okay, I just wanted to take note of that. So if you want to predict the probability, okay, so like I said, the smoker equal to yes, the type equal to response, okay. The first one here, we predict the probability of survivor, for the participant that smoke. And of course, the second one, we actually predict the probability, okay, for those who do not smoke, okay, the survivor of those who do not smoke. Take a look at that. The next thing that we can talk about is predicting the log odds. Like I said, there's a difference between probability and the log odds. I told you the other time we got there are two ways to present the logistic regression output. Okay, we can present that in a log odd form, which I call the logit form, or we present that in probability form. So if I want to make a prediction based on the log odd form, of course, all what I'm just going to do is to plug in yes, meaning in the smoker, yes, plug in one, okay, in the smoker, yes, plug in no, okay, for the case of the log. So this is a way to predict the log off for the two category, okay, using the R code. And at the same time, we can do that of the odds, okay. But right now, what I want to do, because some people may want to argue this out, it is not only, smoking that could determine the survivor, because even if I wanted to pay attention to the result that we have in a regression output, you actually this guy is trying to tell me smoking is significant, but let us see whether adding more predictor we could improve on the performance of the model. And you know what, taking into consideration, additional predictor that we call age, and this time around the age is quantitative in nature. And what you can see here is when I have a diagrammatical plotting of the survivor against age, okay, putting into consideration the smoking habits of the participant. Okay, this is what I actually have. When you take a look at what I'm trying to see here, you're actually going to see that those who do not smoke, we have this is their value, this is their result in graphical form, and those who smoke, okay, this is what we actually have. And some of you may actually be thinking whether is there any significant difference at all between the two groups. Okay, maybe there is something else, okay, that may determine the whether somebody is going to be alive or not, other than whether they smoke or not. Okay, you get what I mean, right? Okay, so we actually now want to incorporate age, okay, and when we incorporate age, okay, we fitted another model. So this is an example of a multiple logistic, but the one we did the other time is actually a simple logistic, because we only consider one predictor. But right now we're looking beyond one predictor, which make it to be multiple logistic regression. Okay, now this is the output now. Okay, if I want to write the logit form of the model, this is what I'm actually going to write. Take a look at that. Okay, all these are coming from the model. And don't forget, I told you the other time that all these guys here, they call log odd estimate. They are log odd estimate. Okay, I just wanted to get that. Okay, so right now this is a fitted model in logit form. Okay, we can also write the fitted model in probability form. Okay, and how do we actually interpret, okay, each parameter? If you want to interpret the parameter here, which means what you are interpreting is the log or the estimates. I'm going to say that again. Interpreting the parameter in a logistic regression model, you are only interpreting the log or estimate. I just wanted to, to be aware of that. So what I'm trying to say, if I want to, how do I actually interpret this guy here, the 7.599221, which we actually call the intercept right here. Okay. But you know what? We're going to say holding age constant when compared to non-smokers. Okay. When compared to not smokers. Okay. The log odd, okay, the log odd for survivor, okay, the log odd of survivor for smokers will actually be 7.5, 7.599221. I'm going to say that again. Holding age constant when compared to the non-smokers. When I talk about non-smokers, I mean the smoker, yes, it is equal to zero. You know what I mean, right? Okay, so the the log odd, not the odd this time around, the log odd. What am I trying to talk about? What am I trying to say? Okay, even I hold age at constant, the log odd, okay, for the survivor for smokers on average going to be that guy. That's what I mean. Okay, but if I want to talk about the odd, okay, if I want to talk about the odd, okay, what I'm going to do, I need to take the exponentiation. Okay, it's going to be exponentiation. I need to take the exponential raised to power this if I want to talk about odds. Okay, but if I want to talk about log odd, I'm actually going to use the result or the estimates in the table. Okay, so I actually want you to get that. Okay, now you remember what I did in class, that if you plug in right now, okay, for the two category, when I come into the the log odd model, okay, I decided to plug in zero here, then it means I actually want to measure how age relate to survivor for those who smoke. When I plug in zero, I'm going to say that again. Okay, if I want to look at the relationship between age, okay, and the log, okay, the log odd, okay, if I plug in zero for smoker, yes, it means I'm interested in those who do not smoke. Okay, I'm actually going to have this. That's what I'm doing here. Okay, and the odd is actually basically going to be the exponential of all of this. When I have the log of something, and when I want to find the odd, automatically I'm going to do the anti-log, okay, which is exactly what I'm doing here. Okay, and if I want to do that for the smoking, for those who smoke, I'm actually going to plug in one. And when I plug in one, okay, the log odd is going to be this, okay, which means I'm actually going to have a new intercept, which is basically going to be 7.6, you're going to be log odd of that 7.60 minus 0.20. You get what I mean, right? And if I want to get the odd of that, I'm going to take the exponentiation of that. So take a look at that. Okay, so the difference in the estimated log odd, if I want to know the difference in the estimated log odd of a life, okay, what does that mean? Okay, I basically want to tell you, okay, that is what what that actually measure. You get what I mean, right? If you take a look at what I have here, okay, so that is what we're trying to find. When you're trying to perform this, I don't know whether you remember what I call the percentage change in the estimated odd of a life. So which is going to be the odd 2 minus odd 1 divided by odd 1. So we've already obtained all this. So if you're trying to plug this guy in here and this guy in here and this guy in here, automatically it's just going to tell you us 2 divided by us 1 minus 1. And when you do that, you're actually get a result that I got in class that is probably 20 points something. You get what I mean, right? Okay, so that is how we got that. Okay, so and what does that mean? How does the estimated probability of a life differ between a smoker and a non-smoker at the same age? Now, what I'm trying to tell you now, okay, if you want to look at that, you can actually plot, the fit probability against the age, and that will enable you, you can actually use a model now to find when somebody is at age 60, okay, you can determine the probability of survivor, whether if it's smoke or not. You get what I mean, right? Okay, so what we are now trying to say now, according to the model B, okay, which smoking status now has a higher probability of survivor? And don't forget, if you take decision using the model A alone, okay, and then if you don't consider age, because I'm seeing age now as an important covariance. I told you when I was teaching something on multiple linear regression, reason why we actually need to incorporate a variable, that can influence the response. If it is missing in a model, it will undermine the performance of the model. Okay, now I just want to tell you that you're actually going to have a different perception now. Okay, when you included age and when you don't include age, and that is the reason why that question is actually talking about, what I'm going to tell you now. I need you to decide based on the lecture I presented today. Okay, which of the question on which smoking status, whether what I mean by which smoking status, are we talking about, whether somebody smoke or not. Okay, which one we have higher probability of survivor if you put into consideration their age as well. If you don't put into consideration their age and you put into consideration their age, you're actually going to have different results. But you know what? I told you the other time, we got to make sure we include an important variable in the model. Otherwise, if an important variable that could potentially influence the outcome is missing in the model, that it means we may not be able to, rely on the model that will affect the model performance. And that is the reason why age is very, very important here. Okay, so this is where I'm actually going to stop. I think I'm going to continue with you in class, but if there's anyone who need clarification on how that works, of course, you can actually visit with me during my office hour. Okay, make sure you guys stay safe and have a good day. Okay, bye for now, guys.